Bismillahirrahmanirrahim. Today we are going to learn about how to measure the chi-square value and check for alternative or null hypothesis. The chi-square test is generally applied on a questionnaire. In the questionnaire we generally have 4 or 5 options. For example, the options can be strongly agree, neutral, disagree, and strongly disagree. The strongly agree is option 1, the agree is option 2, neutral is option 3, the disagree is option 4, and strongly disagree is option 5. Now we are going to apply these questionnaires or these options on different people. The people may be from 1 to 100 or from 1 to 200. These are number of people, and now different people tick or mark different options. For example, the person 1 tick to the neutral, that is 3. The person 2 tick to the disagree, that is option 4. The person 3 tick to the strongly agree, that is option 1. Similarly, different option can be ticked by different people at different times. So because all the people may not be agree, all the people may not be disagree with some opinion, so you can put over here different options. I'm going to copy these options to make it very easy. Now the rest should be deleted. For example, we are going to evaluate the people 137 in number. So now we are going to check that how many people take to the option 1, how many people take to option 2, and how many people take to different option. So the observed values should be written over here in such a manner that you should apply a function. The function should be is equal to count f, then start bracket, and then the range, and then the criteria. Okay, so the range is this one. This is the full range. You will select the full range, and then you will put over here a comma. There is a comma, so you will put a comma over here, and then criteria. Criteria is for strongly agree. How many people tick to strongly agree? So you should close the bracket and then press enter. So it means that 23 people have ticked to the strongly agree. It means that 23 people also take to the agree. It also means that 44 people take to the neutral, and 22 people are disagree. Similarly, 22 people were disagree. I'm going to change these values so that there may be some difference in the values. have changed the values so that there may be difference between the values of observed. Now what is the expected range? What is the expected value? The expected value is always number of all the number is equal to all the number of options, all the number of people is equal to sum, start the bracket and then close the bracket after selection. All the options were 134. All the people who take different options were 134. So total number was 134 divided by how many options? 5 options divided by 5. So it means that 26.8 should be there for each and every option. If we find out the sum of these, this should also be 134. Now we are going to see the observed minus expected value. Observed minus expected. Over here the observed is 22. The expected minus expected is 26.8. So this is the observed minus expected. Similarly, actually we are going to tabulate the data, that's why we are going to find out the observed minus expected value. Now we are going to find out the observed minus expected, or O minus E whole square. How will we find out? O minus E whole square. The O minus E whole square should be is equal to, this is O minus E, and you will put this function and then square. The square of 4.8 is 23 point. Similarly, the square of minus 2.8 is, similarly the square of 17.2 is 295, and similarly the square of this is this. So the function is applied on all the numbers. Now we are going to put the observed minus expected value, the square of observed minus expected divided by expected value. We are going to make arrangement for what? For the chi-square value. So the chi-square value should be calculated like this. First of all, we will put the observed minus expected whole square divided by E. This is the E, expected value. Now you can see over here that these are the observed minus expected divided by expected square. So now what will be the chi-square value? The chi-square value will come over here by the addition of all these. The addition of all these will give rise to observe the chi-square value. Chi-square value is represented by x square. Okay, the x square is there for what? For chi-square value. So the chi-square value is the sum of observed minus expected whole square divided by expected value. Now we are going to sum all these is equal to sum, start the bracket, select the data and then close the bracket and press enter. This is the chi-square value. 15.104 is the chi-square value. We have got the chi-square value, but this is not that simple. We are also going to find out some other parameter, the degree of freedom. What is the degree of freedom and how to measure it? Okay, the degree of freedom is total number of option minus 1. Total number of option were 5, and if we subtract 1 from 5, that is 4. This is the degree of freedom. Now the level of significance. Level of significance is always put by you at the start of the test. The level of significance is generally put in various tests as 0.05. It means that the data have 95% probability to be true and 5% probability to be false. Okay, so 0.05 is the level of significance for which we have put over here. Okay, now we will check. We will find out the critical value for the chi-square critical value. Chi-square, this is very important, critical value. This critical value is used to check for the null or for alternative hypothesis, that the null hypothesis is accepted or rejected. So the critical value is actually the junction point. How to measure the critical value? The critical value, there is a formula that is equal to chi chi-square dot inv dot rt. This one is used for the determination of critical value. So we have put this data. This requires the probability and degree of freedom. So the probability is already, we are having the probability, that is this one, and the degree of freedom, that is 4. Close the bracket and then press enter. This is 9.48. 9.48 is what? 9.48 is actually the chi-square critical value. You can also reduce this chi-square critical value from a table. I am going to show you the table. You can see the table over here. In this table there is the degree of freedom and the probability. The degree of freedom is what? The degree of freedom was 4 and the probability was which was 0.05. So if we cross link the 0.05 with the 4 degree of freedom, so that is 9.488. You can see over here this 9.488 matches our chi-square critical value. So it means that, what does it mean? It means that the critical value is less than the chi-square value. If the critical value is less than the chi-square value, this means that the null hypothesis is rejected. This means that the null hypothesis is rejected. If the chi-square value is less than the chi-square critical value, then the null hypothesis is accepted. In this case, the null hypothesis is rejected because the chi-square value which we have got, that is 15.104, that is more than the critical value. It means that the null hypothesis is rejected and alternative hypothesis is rejected. You can see that the chi-square value is greater than the critical value, so the null hypothesis is rejected and the alternative hypothesis is accepted. If the chi-square value was less than the critical value, less than 9.4, then the null hypothesis is accepted and the alternative hypothesis is rejected. But over here the alternative hypothesis is accepted and null hypothesis is rejected. This value means that that there is a big difference between the selection of each mark. Each mark is selected very precisely, not randomly. You can see over here that the neutral is selected many times as compared to all the other parameters. So when there is a big difference between between different options in the questionnaire, then the chi-square value is, then the null hypothesis is rejected. If the observed value is almost equal to the accepted value, then the null hypothesis is accepted. Then that is nearly the average. Now we are also going to find out the p-value, the chi-square p-value. Chi-square p-value. There is also probability value for chi-square. This is also used in the statistics. that is compared with the level of significance which we have put. We will also check compare the p-value with the level of significance. How to find out this? This can be find out with the help of a formula function, that is chi-test. This is the chi-square test. This one, the chi-square test can calculate the actual range versus the expected range. The actual range is the observed frequencies, and expected is this one. So we will close the bracket and press the enter. Now you can see over here that this value, if I'm going to make it blue, you can see over here that this value is very much greater than the chi-square phi value. This is very much greater than chi-square phi value. So this means that the data which we have got is you can say that 0.4% or 0.5% there is a chance of the data that it can be false, and 99.6% or 99.5% acceptance value, or 99.5% chances of our data to be true, and we have put the level of significance at 0.05. that is very much greater than, that is almost 5%, and this is 0.5%. If we round up this data, then we can also round up with the help of this one. This is 0.04. So this is very much less than this one. So this means that the null hypothesis is rejected and the alternative hypothesis is accepted.